All right, so today we're going to continue on with our triangles, and this time we are going to classify our triangles in the coordinate plane. So continuing with classifying, we're going to work with naming the triangle based on its sides. So we're going to see if it's isosceles, scalene, or equilateral. So we're going to have to figure out the length of each side. Now, to determine the length of each side, you can see here I already have a triangle on the coordinate plane. The points are plotted for us, but it doesn't tell me how long each side is. We have a formula to figure out the length of each side, and I'm going to actually put that up on the screen so we can recall the distance formula. And here it is. Make sure you have this written down if you don't remember it. Again, this is our distance formula, and that's going to help us calculate length. All right, so that's so important. We're going to have to calculate the length for every side we have. And since in a triangle we have 3 sides, we are going to use the distance formula 3 times. So I like to just pick a point to start from and work my way around. Labeling is important so you don't miss anything on your diagram. So I'm going to start at point O. I'm just labeling it on my diagram for reference for where we're going to begin. And I'm going to work my way clockwise around my figure. So I'm going to start with OP. So OP is the first segment I'm looking at. And I'm going to use the distance formula. And I'm going to plug in like I've shown before. So my order pairs are 0, 0, and -1, 2. Again, I like to stack them so then my X's are lined up, my Y's are lined up, and plug into my distance formula. So remember we have our X's here and our Y's right next to it. I like to plug right in and go straight top to bottom. You can go in reverse as long as you do the same for your Y coordinates. So I'm going to have 0 minus -1 squared plus 0 minus 2 squared. We're going to clean up the inside of our distance formula. So here we still have that square root. And now I have 1 squared plus -2 squared. I'm going to square each term inside. So here I have 1 and 4. Simplifying that one step further, I have the square root of 5. So OP is the square root of 5. I'm going to go ahead and highlight that or box it in. You're going to want to make sure you know your lengths for each one. So that's my first length. So we just worked from here to here. Again, I like to mark it off on my diagram so I remember what size I've completed. So now I'm going to go from P to Q. So I'm going to raise this up just a little bit. So P to Q, so here I have P is -1, 2, and Q is 6, 3. So you should pause your screen and try to set up to see if your setup matches my setup. Again, I'm going to plug in from top to bottom. All right, so here is my distance formula. Here's that square root. And when I plug in, I'm going to have -1 minus 6 squared plus 2 minus 3 squared. That is my setup. And now I'm going to simplify like I did in my previous distance formula. Carrying down that square root symbol. So here I combine. This is going to be -7 squared plus -1 squared. Now I'm going to evaluate underneath that square root symbol. So here I have +49 plus +1. Remember, when we square a negative, the answer is going to be a positive. And combine like terms, here we have square root of 50. So PQ is the square root of 50. So we completed this side. Now I'm going to do that one more time. And we're going to go from Q to O. Again, I recommend pausing your screen and trying to solve this on your own. So here we have 6, 3, and 0, 0. All right, so now plugging in. Here we have 6 minus 0 squared plus 3 minus 0 squared. Simplify under that radical symbol. Here we have 6 squared, 3 squared. Now I have square root of 36 and adding 9. So here we have 36 plus 9 under the radical, making it square root of 45. Again, notice I did not take the square root of any number because I can identify what type of triangle I have simply as the answers that we have with the square root symbol. You can evaluate it to get a decimal, but it will still come out to the same result. So here are my 3 sides, and I have QP is the square root of 5, PQ square root of 50, QO is square root of 45. So I have 3 different side lengths, and because I have 3 different side lengths, we could then say, and we have to say, you have to write the sentence, triangle OPQ. This name comes up from the given information that we started with, is a blank triangle. Now we're going to fill in that space right there. So what type of triangle is it? Is it equilateral where all the sides are equal? Is it isosceles where 2 sides are equal? Or is it scalene where all 3 sides are different? And in this case, all 3 sides are different, so this is scalene. Again, it's a requirement that you have that statement. If you forget this statement, you didn't finish the problem. Now, notice I left this side empty because we're really not done with the problem. We're going to go right back up. We only finished part 1. The second part says, determine if we have a right angle in this triangle. Okay, so I'm going to actually draw a line here to break up my work. Now, to determine if we have a right angle, we have to go back and talk about what makes a right angle. Now, we learned a little bit about what makes a right angle in previous lessons. So we know that perpendicular lines create right angles. Now, how do we know when we have perpendicular lines? Well, we know when we can look at the slopes. So this is coming back from Algebra 1. The slopes for perpendicular are negative reciprocals. So that means that we're going to have a positive and a negative value and a flip-flop of each other. So again, I'm going to write that out. We have a negative reciprocal. So an example of that would be 2 and negative 1/2, or negative 5 and 1/5. Notice in each example, one is positive, one is negative, and they are a flip, aka a reciprocal of each other. Now, looking at this problem that we're going to work with, we are going to have to find the slope 3 times. Okay, now to find the slope, there are 2 ways. I'm going to put up a little piece of information. There are 2 ways that you should remember. I'm going to cover this up for a second. You can write this anywhere on your paper. We can use rise over run. This is great when you do have a graph, but sometimes we will not have a graph. And then we can actually use our formula for slope as well. In this example, I will be using rise over run because we do have a graph. Okay, so I'm going to take this down. So again, make sure you have it. I'm going to move that over. So we're going to be working with rise over run. Again, we're doing this 3 times. You can start anywhere. Doesn't matter where you start. I'm going to start in the same order I started from the first one. So I'm going to start with OP. So OP, I start here. Now remember, we're using rise over run in this example. Rise over run, it's going from up or down, and then left and right. So again, I'm just writing that here so we have it. So rise over run. So going from O to get to P, am I going to go up or down? In this example, I'm going up 2, so that's positive 2, and then I have to go to the left 1. To show that I'm going to the left 1 would be negative 1. And then I'm going to simplify this a little further because we know that we can change this and not leave it as a fraction. So this would be simply negative 2. That is my slope for OP. All right, so then here we have the next one. We're going to PQ. All right, I'm going to change my color for this on my diagram. So going from P, getting to Q, the first thing is we're starting here. I have to go up 1. I'm drawing it so you can see it a little bit better, but you don't have to. So up 1, that means I'm on the same line as Q, so I know that that's going to be a 1. And then how many do I have to go to left or right? I have to go to the right, and how many? So 1, 2, 3, 4, 5, 6, 7. And that's the slope from P to Q. My last one is going from Q to O. So from Q to O, we start here, and to get to O, we're going to have to go down 3. So that is negative 3. We're showing to go down. And then we're going to go to the left. 1, 2, 3, 4, 5, 6. Again, since we're going to the left, that's negative 6. We do not leave this as a fraction. We're going to simplify. So we have 3 over 6, which we can reduce to 1/2. Also, we have a negative divided by a negative, which is a positive. So this is a positive 1/2. So I'm going to highlight all my slopes. So we have negative 2, 1 over 7, and we have 1/2. So in this case, negative 2 and 1/2, they are negative reciprocals. So what does that mean? That means that we have a right angle. Okay, so these are these 3 dots. That means in conclusion, in summary of, we have a right angle. So I'm going to write right angle. After you do all this work, finding each slope, you have to tell me if you have a right angle or not. Just showing me the work is not enough. You actually have to state, I know we have a right angle or we do not have a right angle. So the 2 that are the negative reciprocals, I'm going to box them in. So I have OP and QO. So looking at these 2, what letter do they have in common? Right, they have O in common. So that means on the diagram, O is where the right angle would be located at. Okay, so that's just a little bit extra information. That's where the right angle would be at. All you need to provide to me is showing each slope and identifying if there's a right angle or not. All right, so we're going to try some more. All right, so make sure you have this on your paper. I'm going to try one more. All right, this one that says try on your own. It says to classify triangle ABC by its sides, then determine whether it's a right triangle. The very first thing is you should graph your coordinates and label them. When I mean label, you should be labeling capital A, capital B, and capital C on your diagram and connecting the 3 points. So here is my picture. All right, and you're going to go through the process of finding the lengths for all 3 sides. Again, you can start in any order. I'm going to start with AB. So at this time, I'm going to ask you to pause your screen, find the 3 lengths, and try to classify. Then unpause your screen to see that our work matches. All right, so now let's look at what we have. So from A to B, you should have the square root of 18. Okay, so I'm not going to be showing all my steps in this example. So if you do have questions, you can leave it in the comments or email me. All right, and then my next one is from B to C. We have the square root of 50. Then from C to A, we have the square root of 32. So now remember, after you have all three lengths calculated, you have to identify what type of triangle you have by sides. So in this case, again, we have three lengths that do not match. So we can say triangle ABC is a scalene triangle. All right, so that was part one. Now part two is you're going to want to find the slope of all three sides again. So remember, I'm just going to put that reminder up here. In this case, if you have your graph, I would suggest using rise over run, just because that graph is there and it's easy to count. And I'm going to do the same. So again, pause your screen to find your slopes and identify if we have negative reciprocals or not to create that right angle. All right, so now let's look at what we have. So M stands for slope. So slope of AB, when I go from point to point for rise over run, I have -3 over 3, which simplifies to -1. So again, remember that negative tells me if I'm going up, down, left, or right. So here I was going down 3 to the right 3. Right? The slope of the next one, here we have the slope of BC. So BC is -1 over -7. Now with that one, we can simplify one part. We have those two negatives there. We don't leave it like that. So I'm going to clean that up just a little bit, and we can say that our slope is 1/7. Then the last one we have CA. So CA is 4 over 4, and that simplifies to 1. So now looking at the three slopes we have, and I'm going to highlight them. Right? Do we have negative reciprocals? So again, we're looking for a positive and a negative and a flip-flop of each other. In this case, we do. I'm going to circle them. So -1 and 1 are negative reciprocals. So if I even wrote them as a fraction, it would be -1 and 1 over 1. You can see that they are, one's positive, one is negative, and a flip of each other. So here we're going to say we do have a right angle. And I drew my angle symbol instead of the word angle. All right, we're going to continue practicing this skill in class. All right, talk to you guys soon.